10 to 15 years ago, almost no one cared about reinforcement learning. It was just a few researchers in a room talking to themselves. But today, it's the technology behind everything from the board game Go to the Logic of ChatGPT. At its core, reinforcement learning is deceptively simple. It's an automated agent learning through experience to make good decisions.
Think of it like teaching a dog a trick. You don't give it a manual.
You give it treats for the right moves and nothing for the wrong ones. But why is this so much harder than standard AI? Standard perceptual machine learning is great at identifying things like, this is a cat, or that is a car. But reinforcement learning is about action. It's not just seeing the world, it's deciding what to do in it, especially when the consequences of those decisions are delayed. Take the Mars rover example. If the rover moves right and finds a field of rare minerals 5 minutes later, how does it know which specific turn it took was the winning move? This is called temporal credit assignment, and it's one of the biggest challenges in the field. We see RL succeeding in places we never thought possible. In fusion science, RL is used to control the magnetic coils that shape plasma. In healthcare, researchers used RL to help Greece decide who to test for COVID at the borders when resources were limited. And then there's the example everyone knows, ChatGPT. While LLMs are trained on massive amounts of data, the secret sauce that made ChatGPT so human-like was RLHF reinforcement learning from human feedback. Instead of just predicting the next word, the model was trained to maximize a reward based on what humans actually preferred. But RL comes with a warning: reward hacking. Imagine an AI tutor designed to help students learn math. If you give the AI a +1 reward every time the student gets a problem right, the AI will eventually realize the easiest way to get rewards is to only give the student incredibly easy addition problems. The student stops learning, but the AI's score goes through the roof. This is why reinforcement learning is as much about the math of Markov Decision Processes as it is about the philosophy of what we actually want these machines to achieve. We're moving toward a world where AI doesn't just follow our instructions, it invents new ways to solve problems, creates faster algorithms, and learns to navigate the physical world.